Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 24, 2025, just 2 days ago. This paper introduces a new method that uniquely improves a model's performance on every single benchmark it was tested on, including a 6-point increase on InfoBench. The paper is titled, "Checklists are better than reward models for aligning language models," and the implications for how we fine-tune these models are pretty significant. The authors argue that current alignment methods struggle with complex instructions, so this new approach uses flexible, dynamic checklists instead. Alright, so the core of their argument is visualized in this first figure. It shows the results of fine-tuning the QN 2.57b instruct model. They use a technique called direct preference optimization, or DPO, which teaches the model by showing it pairs of responses and simply telling it which one is better. Looking at the chart, the red bar represents their new checklist method, and it's the only method that improves performance across all 5 benchmarks. The other techniques, in blue, give mixed results, sometimes helping, but sometimes hurting. This result really highlights how the checklist approach provides a uniquely consistent and reliable improvement. So how does this method actually work? This diagram lays out the process, which they call reinforcement learning from checklist feedback. It starts with a user's prompt. The teacher model then automatically generates a specific checklist from that prompt's instructions. For instance, checking if a list was provided, or if the number of people was correct. The student model, the one being trained, then generates a few different responses. Finally, the teacher grades each response against that checklist, creating a detailed score that teaches the student which answer was better. Building on that, this table digs into how they create the best checklists in the first place. They compare 2 methods, a simple direct prompt and their new candidate-based approach. They evaluated the checklists on qualities like objectiveness and atomicity, which just means how specific and verifiable each item is. While the direct method was a bit more natural sounding, the candidate-based method was consistently better at being objective and comprehensive. And looking at the bottom row, percent preferred overall, the candidate-based method was clearly the winner, making it the superior choice. Building on that, this table digs into how they create the best checklists in the first place. They compared 2 methods, a simple direct prompt and their new candidate-based approach. They evaluated the checklists on qualities like objectiveness and atomicity, which just means how specific and verifiable each item is. While the direct method was a bit more natural sounding, the candidate-based method was consistently better at being objective and comprehensive. And looking at the bottom row, percent preferred overall, the candidate-based method was clearly the winner, making it the superior choice. Okay, so this next figure provides a great conceptual map of where this new method fits in. It compares different ways of evaluating model responses. You have fine-tuned evaluators, also known as reward models, and prompted evaluators, which are basically AI judges. The key difference is along the bottom, the number of explicit criteria they use. Most methods, like constitutional AI, use a small, fixed set, maybe 16 rules at most, but their checklist feedback is way off the chart. It's like an AI judge with access to over 300,000 criteria, pulling a unique set for every single instruction. Alright, so moving to the actual results. This table compares the new checklist method against other approaches on 2 key benchmarks. On the left is IF eval, which tests how well the model follows strict formatting rules. And on the right is InfoBench, which is more about following open-ended, content-based instructions. The key takeaway here is that their method, reinforcement learning from checklist feedback, is the only one to show consistent gains, with the scores in bold. The other methods give mixed results, sometimes hurting performance. This outcome really underscores the reliability of the checklist approach. Alright, so we've established that the checklist method is really effective, but this next table digs into a crucial detail. Does it matter how the checklists are created? Here, the authors compare training with checklists from a simple direct prompt versus their more advanced candidate-based method. The numbers show that the candidate-based approach is consistently better across the board. It leads to a 2% gain on IF eval and a 2 to 3% boost on follow bench. This outcome highlights that the quality of the checklist itself is vital. So to wrap things up, The big takeaway is that using these dynamic, instruction-specific checklists is a more robust way to teach models how to follow complex instructions. The proposed method, reinforcement learning from checklist feedback, or RLCF, was the only approach that improved performance across every single benchmark. It works by creating a custom checklist for each instruction, scoring the model's response against it, and then using those scores to fine-tune the model. And as we saw, the quality of those checklists is absolutely critical for success. That's all for this edition of the AI Research Roundup. Thanks for tuning in.